Suppose that we have an arithmetic sequence. So let's say it goes like this. It's maybe 4, 7, 10, 13, 16, etc. And I want to know the sum of the first 100 terms of this sequence. Okay, so here's what I'm going to do. I'm first going to calculate the value of the 100th term. And so that's going to be 4 plus 99 times my common difference, because I will have added 99 times to get from the first to the 100th term. And so that's going to give me 4 plus 3 times 99, which is 297. So that's going to be equal to 301. And so the way I'm going to envision this is that I know that if this is my first, and I know that my last term is 301, then I also know that my second term is 7, my second to last term is 298. My third term is 10, my third to last term is 295, and then I have 13, 292, etc. Well, what we'll notice is that when we sum these, we end up with 305. 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 And so what we end up with then is, because there are 100 terms, we end up with 50 pairs. And so each pair sums to 305, so we end up with 50 times 305, which is going to be 15,250. And that's our sum. So what we did was said, okay, we're going to take the number of terms and divide that by 2 to get the number of pairs. We're going to say that each pair is equal to the first term, a sub 1, plus the last term, which is a sub n. And that's our sum right there. Well, we can then go further and say n over 2 times a sub 1 plus, and now to get an expression for this, we know that it's got to be equal to a sub 1 plus n minus 1 times d, where d is the common difference. And so really, in a nutshell, that is the formula for the sum of an arithmetic sequence. And it's not something that I want you to memorize, but what I do want you to memorize or understand how to do is this process here, where we figured out the value of the last term, and then we just figured out how many pairs there are, what each pair sums to, and then use that to calculate. Now notice if we'd had, instead of, let's say we had, 4, 7, 10, 13, 17, well then we have n over 2 is actually an odd number because it's equal to 2.5. But when we're summing these, we would say we have one pair that adds up to, this should be a 16 here. We have one pair that sums up to 20, a second pair that sums up to 20, and then we have a half pair that sums to 10. And so the formula still works. So we would have 2.5 times the sum of our first and last terms. 4 plus 16 is going to give us 2.5 times 20, or 50. And if we add these together, we get 20, 40, 50. So that works. Okay, so that's how we do it for an arithmetic sequence. Now for a geometric sequence, it's a little different, not surprisingly. So suppose we have the sequence that goes 3, 4.5, multiplying by 1.5 each time, 6.75. And the next one would be, 9, 10.125. I believe that's right. So here what we're going to do is this. We're going to say, if we want to know the sum of this, then what we need to do is we need to figure out what this, so we have our common ratio, first of all, which is that it's equal to, the ratio is equal to 1.5. And so what we do is we say, all right, 1.5s is equal to 1.5 times all of these terms here, which is going to give us 4.5 plus 6.75 plus 10.125 plus plus 15.1875. And then we're going to subtract. We're going to subtract 1.5s minus s. So on the left side, we get 0.5s. Over here, we can see that all of these will cancel out except for the last term here and the first term here. So we end up with 15.1875 over or minus 3, which gives us on this side 12.1875. So we end up with 12.1875 divided by 0.5, which is just going to end up being equal to 24.375. So 24.375. So the idea here is that we needed to figure out, for our sequence, we needed to figure out the last term, if that was not known to us. Then we actually need the term beyond that when we multiply through by the common ratio. So suppose, for example, we wanted to figure out what's the 10th term, or let's say what's the sum of the first 10 terms of this sequence here. Let's say we start with 3, 6, 12, 24, ... Okay, we want to know the sum of the first 10 terms. Okay, so the 10th term is going to be equal to 3 times 2 to the 10 minus 1, or to the 9th, which is going to be equal to 3 times 512, or 1536. Okay, so what we need to know now is we know that S is equal to 3 plus 6 plus 12 plus 24, all the way up to plus 1536. Well, our common ratio is 2, so we're going to multiply by 2 to get 2s is equal to now 6 plus 12 plus 24, plus we're going to get another 1536, but then we're also going to get double the 1536, which will be 3072. So when we subtract, on the left side, we're just going to get s, 2s minus s. On the other side, on the right side, everything cancels out up until we get 3072 and 3. So we get 3072 minus 3 equals 3069. And then we would, in this case, divide by the coefficient of s, but we already know that that's 1, so we end up with just 3069. So generally what we have here is we have, as a general rule, we're going to have our last term, but it's actually we'll start with g sub 1 times our common ratio raised not to the n minus 1, but to the n, so that we get to this number here, minus g sub 1 over, and what we ended up doing on the left side here was we end up with s times, in this case, 2 minus 1, and so we ended up with s times our common ratio minus 1, and so we divide everything through by our common ratio minus 1 to get r minus 1. So this gives us a general formula. But again, the idea is that you want to take your series, you want to multiply it by the common difference, or the common ratio, and then divide by that common ratio, and then work the rest through algebraically to get the sum. That's the trick here.